And we are back at our training domain, specifically our car access model. Hello, my name is John Kakabara. I am the chief architect of Radius, and we are going to tackle distributed caching. The distributed caching mechanism we currently use is a product from Microsoft called App Fabric Caching. There are lots of materials out there on the net about this subject. Specifically, Pluralsight has some good information. I am not going to delve into the ins and outs or the benefits of distributed caching, and I'm not going to talk about how to use App Fabric specifically, as that material has been covered by others. I will also say this. At the time of this training session, which is September 11th, 2015, we are using Microsoft App Fabric Caching, but we have plans to move on to Redis caching. Microsoft will no longer be supporting App Fabric caching, and they have suggested to move on to Redis. And Redis is a product that I have some idea of and think is good and is used quite widely. It is an open source project, so we'll be moving in that direction. There is also a lot of information out there on Redis, including a Pluralsight class. With that, let's get started. Now, last time we ended in the previous session, we put together a repository and a get initial state operation that included not only the car, but car type and fuel type information. At that time, we were using the internal static cache that Frameworks creates automatically when the isType table is true. And for a number of reasons, I said that the static cache, while very, very fast, has a lot of drawbacks, and that we much prefer using distributed caching in all but the absolute most demanding performance circumstances. So we're going to change the car type cache over from a framework static cache over to the distributed cache. So the first thing that I already did was I went in and I chose false for the isType table. The next step would be to extend the DAO. After all, accessing data, whether it's in a database or a distributed cache, is still data access. So that's why I'm putting the cache code in the car type DAO. Let's look at it. I'm extending the iCar type DAO with a get all car types, and I'm going to return an array of car type. The get all car types will try to get the data cache engine cache item that is keyed by all. And if the cache item does not equal null, we coerce the cache item as an array of entity.cardType, and we're done. Let's talk about the data cache engine. The data cache engine is imported, and the data cache engine is a CPI core caching App Fabric class, and this class wraps all of the specific API of the App Fabric caching engine. Feel free to go in there and take a look at how we do it if need be, and just remember that we will be moving on to Redis, so I will be creating a Redis adapter for the data cache engine. If that cache item is not there, then we continue with this piece of code and we call a method called manage cache, So the idea is here now that we did not find the item in the cache, so it has either been evicted from the cache, or we're just starting up the farm and we're the first process that needs the card types. Manage cache will go to the database, and it will use the nhibernate DAO queryable to put all those card types in an array, and it will return the array, and we will get the card type list out of the array and return it. That's all well and good, except for one problem. Every time we walk in this method, it's never going to find the key of all, and therefore the card types, because we never put the data in there. So part of the managed cache job should be to actually put the data into the cache, and that's what we'll do now. The data cache engine has a method called put, and we will pass it the config, which I will show you in a minute, and we will pass it a key. We'll call it all, and we will pass it the return value. So now I'm putting the returned value, the array of card types, into the distributed cache, so it will be there the next time not only this process calls for it, but any other process on the same server or other servers on the farm that calls for it. Pretty simple stuff. I want to talk about the config for a moment. So we declare the config. It's actually a configure persistence helper, and we give it the name of the data cache factory, and we give it a data cache name, in this case car type container, and and we append the database name appender. What's that? Well, we have different environments: production, QA, development, etc., etc. And when we share resources, and in the case when we share, for example, a database server, our dev boss SQL 001 database server not only holds databases for QA, but development and QA2 and UAT and several others. We need a way to distinguish between those databases on that server. Let me see if I can show you that real quick. So where are we? So I'm on my local database here, and when we're on our local, we don't need to, the database name appender will be blank because we don't need to distinguish it. But when we are on a server, such as DevBoss SQL N01, we would need to distinguish the QA2 environment with the QA3 environment and the UAT environment. So these guys are the appenders here: QA, QA2, QA3, etc. Well, we would need to do the same thing if we were sharing the distributed cache. So that's what the database name appender is for. Anytime we call the data cache engine, we have to pass it this configure persistence helper object, so it will know where to go to get the to connect to the cache and how to treat it. That information can be tracked all the way back to the base configuration. Now, the base configuration is in a folder called Settings, HSP NextGen, Base. Oh, I need to not open a project, but open a file. Engineering, Settings, HSP NextGen, Base Configuration XML. So that's where that is. And we can see that we have a data cache factory configuration list, And this data cache factory has a data cache factory name. That's main. And that leads back to the data cache factory name. The data cache name where are we? We are at the data cache configuration. The data cache name, the data cache name, I don't have a, what do we call it, car type container. So I could name this, I could create a new data cache name called car type container, database name appender, and we would be good to go. Now remember that I said that I wasn't going to talk about how to configure the App Fabric data cache, and I'm not going to. I will just leave it in saying that you would have to go into PowerShell and you would have to tell App Fabric about this new data cache that you want. Okay. You will also see up in the data cache configuration where the data cache server is, and this is from a piece of data that's embedded data cache cluster name. So this is nothing but a token, and at environment configuration time, that token data cache cluster name is replaced by the token from the environment's tokens file. So in this case, the local tokens.xml, if that's what I'm using, will look at the data cache cluster name, jkakavar9-VM, and there's my port number. So that's how the system knows how to attach to the App Fabric and on what server. Not too difficult, a couple moving parts, but the code is fairly simple. And now we have moved our static cache car type into the distributed cache car type, and we are good to go. So let's try compiling this. Build solution. And we see that we do have one error. Let's go there. And we see that this error comes from the call that we were making when we were utilizing the framework static cache. So let's just change this to get all card types. And that's about it.